betcha that we'll All right. So on Friday of last week, we talked about inverse sine, and we said that the notation for the inverse sine was your classic inverse sine. We also said that we have a new one called arc sine. And we graphed it. And instead of it being a horizontal wave function, we'll just go, there's more room, okay? We said it was a vertical wave function. And the problem with that then is that it's not a function. So then we said, okay, so let's limit our answers, or where we can find our answers that we need. From negative pi over 2 to positive pi over 2. So our outputs from the inverse sine or the arc sine have to be in between negative pi over 2 and positive pi over 2. And that allows us to have every possible outcome, okay? Because it's the right half of the unit circle. Then we did two of them. We did these first two. We did arc sine of 1/2. And so what I had said in my classes on Friday was, okay, right half of the unit circle, where is the sine equal to 1/2? And we said for this first one, sine is 1/2 at pi over 6. Then I said in my class, where on the right half of the unit circle is sine negative 1/2? And everybody almost unanimously said it's at 11 pi over 6. And I said, whoa, 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 that's not in that range of negative pi over 2 to positive pi over 2. So then we tweaked that, and we said that this was negative pi over 6, because the angle of negative pi over 6 is the same as 11 pi over 6. But it fits within our output possibilities of the arc sine. Okay? So that's a refresher from Friday. What I would like you to do now is I would like you to take a moment to find me these 4 values, please. Inverse sine of root 3 over 2, arc sine of 2, arc sine of 0, and inverse sine of negative. All right, talk to me. Where right half of the unit circle is sine root 3 over 2? Pi over 3. Does everybody agree with pi over 3? Love the pi over 3. Okay. Where right side of the unit circle is the sine 2? Nowhere, right? Because what does sine have to be in between? Negative 1 and positive 1, right? Okay. So it's got to be in between negative 1 and positive 1. So it can't equal 2. So this is not possible. Where right side of the unit circle is arc sine 0. Or so where is the sine 0, I should say? At 0, right? Where right half of the unit circle is sine -1. Negative pi over 2. You want to say 3 pi over 2 there, because that's what it is on the unit circle. But this is another one of those, it's got to be negative pi over 2. Huh? Handle? Bless you. Okay. All right. Let's move on to cosine. Huh? So y equals cosine of x. Refresh my memory, because sometimes it gets a little foggy up there. Okay? Refresh my memory. Where does cosine start? In terms of verticalness. High, middle, low. Cosine starts at high, then goes middle, then low, middle, and ends at high, right? Okay? Horizontally, where does cosine start? At 0, right? Or 2 pi, right? Okay? So it would start at any of the multiples or any of the multiples of 2 pi. Okay? So it starts up at 0. Or at 0, it starts at high, and it goes down and back up. Other way, it goes down and back up. So then this would be 0. Oops, I got it. It's just OCD's kicking in. Close. Better. It's better this way, horizontally. So 0's there. So then this would be, that would be, that would be, and that would be. This would be, that would be, that would be, and that would be. So those are in pi over 2 increments, right? So this would be positive pi over 2, positive pi, 3 pi over 2, and 2 pi. Going the other way, it'd be negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Right? Vertically, what is it in between? Between 1 and negative 1. Okay? Domain, all real numbers. Range, in between negative 1 and positive. All that. Okay? Now, refreshing from Friday. When I take the inverse of that, I would switch the x and the y, right? So then this would become y equals the inverse cosine of x, or y equals the arc cosine of x. So give me a point based off of my cosine graph. Give me a point on the inverse graph. Do we agree with 1, 0? Because the point 0, 1 was on our original one. So we would go through the point 1. So it means we're going to have to go out to negative 1, from negative 1 to positive 1. And so you're saying we would be at 1, 0. I would agree with that. Be another one. What do you got? 0 comma pi over 2. Be another one. -1 comma pi. Zero comma 3 pi over 2. One comma 2 pi. So that one's going to come in like this, like a wrecking ball. Oops, I went too far in that. So on and so forth, right? So this would be negative pi over 2. This would be negative pi. This would be negative 3 pi over 2. This would be negative 2 pi. Right? What's wrong with cosine? Not a function, right? Okay? So we gotta restrict it. So the way that we are going to go about restricting it is still need all the values from -1 to +1. But now we're going to go from 0 up to pi. So all of our outputs for inverse cosine are going to be between 0 and pi. Where is that on the unit circle? That is the top half of the unit circle. And the reason that we do that, the reason that we restrict it there, is because it goes back to what we were in geometry. Now, with inverse cosine, you can find it out to which is why the trees just kitty corner to us right now are literally learning in the law of cosines. You find the biggest angle first in the law of cosines because it allows it's the only one that allows you to find. Okay? So forgot that was one. We already did that one. We did that one already. We restricted it on. I forgot that I had a separate slide for that. Okay. So now, again, same thing, except so for the first 1, 2, 4, and 7, okay, we'll deal with those. We'll deal with those first, and then we'll get into the other ones. Okay. So now you're asking yourself. So now you've got to ask yourself, which function am I doing? Because it depends on where I'm looking on the unit circle. So if I'm looking for sine, like we were doing Friday and earlier today, I'm looking right half of the unit circle for sine. If I'm looking at cosine, looking top half of the unit circle. So in number 1, it says, where on the top half of the unit circle is cosine root 2 over 2? Pi over 4, right? Where is the x value of the square root of 2 over 2? I go top half, and I'm only looking top half, so I'm looking at x's. No, yep, boom, pi over 4. Now, Ashley, here's the best part of cosine. Okay, ready for it? So in this next one, now, we were dealing with sine. We would go down, right? We have to look down for it. And then we have to make our angles negative, right? Okay. Now, with cosine, it's whatever it is on the circle, because I'm only looking top half, and those are all positive angles anyway. So I'm looking at my x value. Where is it? Negative root 3 over 2? Nope. Yep! 5 pi over 6. Boom, done. The best part about cosine is it's whatever's on the unit circle. It's none of this. I got to figure out what the negative angle is. We save that for sine. Okay. Do 4 and 7 for me right now. 4 and 7, and then we'll talk more about the other ones. 4 and 7. Where top half is cosine 0. Pi over 2, do we agree with pi over 2? Straight up, pi over 2. Where top half is cosine negative 1/2. 2 pi over 3? Agree? Yep, I would agree with that. Yeah. Any questions on those? That's the nice part about cosine. Straight up. Okay. Now, let's get rid of the sine ones. So let's do 5 and 6 next. And we'll do them together. Right half, because now we're talking sine again, right? Inverse sine, arc sine, looking right half of the unit circle, where right half is sine 1/2, pi over 6. Where right half is sine negative root 2 over 2. You want to say 7 pi over 4, right? But that's not within that range. So what is? Negative pi over 4. Yep. Okay. Now, we've got these other 3. These last 3 remaining. Okay? Secants and cosecants. They follow their partner function. Okay? So that hasn't changed. Secant still goes with cosine. Cosecant still goes with sine. Everything is in code. Okay? You're just looking now at the reciprocal of the answers. Okay? So when I see cosecant of 2 here, what I'm really asking myself here is cosecant goes with sine, so I'm looking for the inverse sine of 1/2, because in my brain, I'm reciprocating 2 because I'm reciprocating cosecant into sine. Okay? And that one then becomes exactly like number 5, pi over 6. Okay? Secant goes with cosine, right? So in my brain here, I'm thinking of inverse cosine of 1 over negative root 2. That's not on the unit circle, is it? What is it? What are you going to do? There you go. I was wondering if you were going to pick up the R word. Okay? So that's really the inverse cosine. So cosine, I'm looking where in the unit circle? Top half. So where on the top half is cosine? Negative root 2 over 2. Three pi over 4. So this one is 3 pi over 4. Okay. Questions on either one of those? I know we got to go up for one more. One more to do. Just want to make sure we're good on those before we go back up. Okay. Arc cosecant. Same as inverse cosecant. Reciprocal of inverse, what? Easy music, yes. Okay, so it's reciprocal of sine. So this is inverse sine, reciprocated the function, so I got to reciprocate the number thing, right? What's the reciprocal of 1/2? 2. Sine is right half of the unit circle. Where in the right half of the unit circle is sine 2? Nowhere, right? Can't happen. Not possible. That's why I saved that one for last. Okay. That's what I thought. I thought that was that. So now what we're going to do is now I'm going to give you a note sheet here, and it's got some questions and some more problems for inverse cosine at the top. Then it's got some more questions and on inverse sine on it. But then you are going to, for the rest of the time, so for the next 40 minutes, the next 2 mods, you are going to discover the inverse tangent function by graphing tangent, then switching the x's and the y's, and doing exactly what we did with that. Okay? Okay? So that's what we're going to work on here now for the remainder of the time. And, oh, that is so red, my sheet. Why? Why don't you magnetize? Side note, if you haven't taken a peek at the back board lately, we have updated it to include the virtual day. So this week, Friday, you'll have a formative, and next week, Thursday, will be the test. The test will be on 4.5 and 4.7. 4.5 was graphing the 4 other functions. 4.7 is, we're getting into it now, that's the inverses, and then tomorrow we'll do compositions, like where we'll say the sign of the inverse sign of root 3 over 2. Yep.